Hi everyone, have a great day. I am Christiana Babe Damo, and the topic that assigned to me is all about the perpetual calendar applications of congruence. History of the perpetual calendar. Who invented the perpetual calendar? Thomas Mudge in 1715 to 1794, an English watchmaker and also the inventor of the detached lever escapement, is credited with designing the earliest perpetual calendar pocket watch in 1762, but Patek Philippe patented the first in wristwatch form in 1889. What is perpetual calendar? It referred to in French as the quantime perpetual, and also perpetual calendar watch is a mechanical timepiece that tracks a wealth of calendar information and properly displays it. The information typically includes the day of the week, date of the month, leap years, and also the moon phases. How does perpetual calendar work? This sophisticated movement has a mechanical memory of 1,461 days or 4 years. A wheel rotating once every 4 years drives the calendar indications in relation with the month's precise length. Most perpetuals have separate mechanisms for each of the calendar indications that are then synchronized by a long lever called the grand lever that runs across the top of the compilations. What does the calendar tell us? There are 6 elements involved in our formula. Using an example date of Monday, 13 January 1964, we have the following elements. Day of the week, which is Monday, date is 13, month is January, century is 19, and year is 64, and 1964 was a leap year. Even if this seems obvious, it's essential to be aware of all the different factors that influence the formula. Structure of the question. The most accurate answer can be given if you have 4 of the above mentioned elements of a calendar. Examples. What was the day of the week? If you have July 14, 1949, you can calculate that it was a Thursday. What month was it? If you have Thursday the 14th, 1949, you can calculate that the month was either July or April. The answer most likely to be required is the first example. This is also the simplest calculation. Calculating the answer. Each given element has to be converted to a numerical value and then be added together for the final answer. Using an example date of July 14, 1949, the different values would be determined the following ways. In this table, we should find the value of the day of the week. We can see in the table the element of perpetual, which is the date, month, year, century, and the day of the week. So we can see also the method, example, and the value. So in the date, the method is the same value, example is 14, and the value is 14. In the month, the method is set value, calendar key, July, and 0. In the year, the method is calculation, example is 49, then value is 5. Century is a set value, 19, and 0. So to get the final answer, we should add the date, month, year, and century, then divide by 7 because the week is equal to 7 days. So the answer is 2, then the remainder is 5. So the day of the week, the method is set value, example is Thursday, and the value is 5. Using the Marais formula. Date value plus month value plus year value plus century value is divided by 7. Calculation. You add up all the calculated values and divide by 7. The remainder is the answer. Fractions are not used. Noted that if it is a leap year and the date is either in January or February, subtract 1 from your final answer. Let's have example. On what day was the 14th of July, 1949? The formula used date value plus month value plus year value plus century value divided by 7. So 14 July 1949, 14th day plus 0 month plus 5 years plus 0 century is equal to 19. 19 divided by 7 is 2 with 5 remaining. The final value for the day of the week is 5. Thus, the answer is Thursday. And now let's know the value of the day of the week, date, month, year, century, and also the leap year. So first is the value of the day of the week. The values are set and range from 0 to 6 starting on Saturday. Saturday is 0, Sunday is 1, Monday is 2, Tuesday is 3, Wednesday is 4, Thursday is 5, and Friday is 6. Next is the value of date. The date value is the date itself. The third one is the value of month. The calendar key is utilized and is a set value attributed to each month. This is the central element that will enable you to do the whole calculation in your head. It is a 12-digit number that you will need to memorize. So in the table, we can see the 12 months and we should memorize the 12-digit, which is 144025036 So we should memorize this 12-digit. Next is the value of year. This is the only part of the formula that involves a bit of arithmetic, and it is calculated the following way. Any given year must be divided by 4. The answer must be multiplied by 5, and then that answer must be divided by 7. Note that you only work with the whole numbers, no fractions are used. The remainders of your first answer and your last answer must be added to give you the final value. Example, if the given year is 49, 49 divided by 4 is equal to 12 with 1 remaining. 12 times 5 is equal to 60, and 60 divided 7 is equal to 8 with 4 remaining. So add remainder of 1 to remainder of 4. That gives you 1 plus 4, and the final answer is 5. Next is the value century. The century values are set the following way. It has a set value of either 6, 4, 2, or 0. If a century is divisible by 400, then the value is 6. The following century would have the value of 4, the next one would have the value of 2, and the following one is 0. And the last one is the leap year. The final element that will influence your answer is whether the date in question falls in the leap year. If it is a leap year and the date is either in January or February, subtract 1 from your final answer. How do you determine whether it is a leap year? If a year is divisible by 4, it is a leap year. In such a year, the month of February will have one extra day, the 29. Examples: 1972. 72 is divisible by 4, thus it is a leap year. 1789. 89 is not divisible by 4, so it is not a leap year. It follows that every fourth year is a leap year, but there is an exemption to this rule. At the turn of each century, a leap year is skipped, except if the century is divisible by 400 Gregorian calendar reforms. Examples: 1700 is not divisible by 400, so that year was not a leap year. 2000 is, so it was a leap year. Now let's proceed to the Julian calendar conversion. Up to October 10, 1582, a calendar was used that was introduced by Julius Caesar in 45 BC. This calendar covers all dates from January 1, 4713 BCE or before current era. The major difference between this calendar and the current Gregorian calendar is that it had every fourth year as a leap year, including every turn of a century. This led to the calendar being incorrect with an error margin of 10 days by 1582. The Gregorian calendar corrected this by dropping the leap year at every turn of the century except where the century is divisible by 400. To convert to Julian calendar dates, follow these steps. First, using the memorized formula, add the date, month, and year values. Second, add 1 day for each century prior to the 1500 example. For 1100, you add 4. For 700s, you add 8. Subtract 1 day for each century after the 1500s. Example, for 1900, you subtract 4. For 2100, you subtract 6. Number 3, add 3 to your final answer. And number 4, divide by 7. And the remainder is the answer, no fractions. Let's have an example. October 13, 1307. Number 1, using the memorized formula, you calculate a value of 22. Number 2, add 2 for the century value, which is 1500 to 1300. Number 3, add 3. The number 4, divide the total by 7 with the remainder as the final answer, and fraction are not used. So 22 plus 2 plus 3 is equal to 27. So 27 divided 7 is equal to 3 and the remainder is 6. So the final answer is 6. And it is Friday. And that's all, and have a great day everyone.